Hello, in this video I'm going to be showing you how to find out where a parabola and line intersect. In this clip you'll be discovering how to replicate this Desmos graph using abstract algebra. So let's begin by looking at our XY graph, and this parabola over here is going to be the equation y equals ax squared plus bx plus c, and this line over here is going to have the equation y equals px plus q. Now what we are looking for is these intersections over here. So we have to make these two equations up here equivalent to one another. So what we get is ax squared plus bx plus c is equal to px plus q. If we form this equation, we'll be able to find these intersections right over here. So let's form this equation over here, like I said, and let's simplify it and isolate x. If we subtract px and q from both sides of this equation, we get this. And if we simplify this equation over here using the distributive method, we are going to get this equation right over here. Now from here we can use the quadratic equation to isolate x, and this allows us to get the x coordinates of these intersections, and if we have the x coordinates we can plug them back into this equation over here, px plus q, to get the y coordinates of the intersections. So now recall with the quadratic equation, when ax squared plus bx plus c is equal to 0, x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Now using this logic over here, right, we can apply it to this equation over here to isolate x. Now since in this case the large A is going to be equal to the small a, the large B is going to be equal to b minus p, and the large C is going to be equal to c minus q, okay? What we get for the value of small x is b minus p plus or minus the square root of b minus p squared minus 4a times c minus q over 2a. Okay, so what we did is we used this logic over here, and we got this equation over here, and we transformed large A, large B, and large C into these values over here to get the value of small x. Now just before we derive the y coordinates of the intersections, I'd just like to say, if you want to know how to derive the quadratic formula from scratch, I've left a link to my previous video below this video which shows you how to do it. So for small x we have this expression over here, and remember we have the line y equals px plus q, okay? So if we plug this value of small x into this over here, what we find is that the intersection points will be this for small x and p times small x plus q, okay? These are the coordinates of the intersections. Obviously a cannot be equal to 0, otherwise we do not get parabolas. And also whatever is underneath these square root symbols cannot be negative because we're only dealing with real numbers. Okay, let's check our results on Desmos. These are the intersection points over here. We've made these coordinates, and we have the graph y equals ax squared plus bx plus c, and we have the line y equals px plus q. If everything is correct, when we change these variables, we'll see the points, the intersections, move as well. Okay? And that is exactly what we see. Everything is consistent. I've left the link to this graph just below this video, so you can play around with it and check out the results for yourself. If you have any questions related to this video, leave them in the comment section and I'll get back to you as soon as I can. For more mathematics content, check out my Instagram page, mathematics.proofs. I hope today's clip has been useful to you. See you in my next video.